Hello, my name is Kevin John, and I will be presenting our work AdapTics, a toolkit for creating adaptive tactile sensations. The hardware this work focuses on is mid-air ultrasound haptics. This technology, in contrast to traditional vibrotactile haptics, allows us to unobtrusively project sensations onto the user's hand. The technology operates by modulating the phase on an array of ultrasonic transducers to create areas of high acoustic pressure in space. These areas can then be perceived by tactile receptors in the skin as haptic sensation. Some features of this technology, besides being contactless, it is highly flexible in the sensations that it can create. For example, by quickly moving the focal point, we can draw basic shapes onto the user's hand. We're also able to emulate many of the parameters of traditional vibrotactile, such as AM frequency, duration, intensity, and rhythm. In order to create haptic sensations, designers can program against software APIs, which are flexible but can impede creative exploration. Alternatively, graphical design tools present a more user-friendly environment and encourage experimentation, but at the cost of restricting design flexibility. In particular, design tools largely focus on creating predefined, unalterable sensations, or non-adaptive. These can be insufficient in interactive scenarios. To expand on this, traditional non-adaptive tactons are unable to continuously adjust at runtime in response to user interaction or changes to application state. Because of this, they are limited in the depth and range of information they can convey. They are also unable to seamlessly transition between sensations and might be found repetitive. All of these factors can lead to an overall less engaging and potentially less effective haptic experience. This gap in the design process highlights the need for tools that enable the creation of adaptive tactons, which are tactile sensations that can change at runtime in response to arbitrary inputs. This draws much inspiration from the prevalence and usage of adaptive audio in video games. This example is to better illustrate the difference in interactivity between non-adaptive versus adaptive. While the non-adaptive tacton can only be triggered in response to certain events, the adaptive tacton can be used to provide continuous dynamic feedback throughout the interaction. By utilizing tactons that support runtime adaptations, designers are able to create much more expressive haptic sensations. To more formally describe the abilities of adaptive tactons, we present a design space with 5 dimensions. Granularity describes where the adaptations are applied, either affecting the pattern as a whole or just a subset of the tacton. For adaptive timing, the speed and specific sequence of playback can be manipulated at runtime. Spatial configuration describes adaptive scaling, translating, and rotating. And similar to traditional vibrotactile, designers can also adapt the qualitative sensation with intensity or any of the ultrasound modulation parameters. Finally, the 5th dimension describes how exactly external parameters are mapped to changes in the tacton sensation, either with formulas or with conditional triggers. We built this design space into AdapTics, an open source toolkit for rapid prototyping of adaptive sensations. The largest component is the designer, which is a web-based graphical design tool for creating and testing adaptive tactons. Complementing this is the engine, a native application and software library to render the tactons created with the designer on haptic hardware. Additionally, the Unity package, which is a high-level wrapper for the engine, enables easy integration of adaptive tactons in Unity scenes. Notably, it allows using any Unity-compatible body tracking system for haptic playback. The primary component of the toolkit is the graphical design tool. It is web-based but still supports real-time playback of haptic sensations and has had significant attention paid towards its performance. In the next set of slides, I'll walk through the main parts of its interface and its features. All designs start by creating keyframes, either in the pattern design canvas or in the timeline pane. These keyframes describe the specific haptic sensation at that point in time, for example, the sensation's location or its intensity. Using the keyframe editor in the right pane, the haptic sensation can be modified for an individual keyframe or for a group of multiple keyframes at once. In the next tab over, called Post-Processing, effects can be applied to the entire tacton. To enable adaptive features, AdapTics allows parametric design of tactons. External parameters can be added from this pane in the bottom left. For example, in a VR environment, the designer may have a parameter that represents the heartbeat of a player, They can define that parameter here and then use it anywhere in their tacton. These parameters also can be manually adjusted during testing from within the designer. There are two ways to use external parameters in the tacton. The first way is with conditional jumps. These enable conditionally changing the sensation, and also can be used to adjust the temporal sequence of a tacton. These are dimensions 2 and 5 from the design space. The second way is through formulas. Formulas are critical to creating adaptive tactons, because instead of exposing individual low-level haptic sensation parameters to an application, the designer can expose or expect high-level parameters to be set at runtime. In this case, the designer wants to change the size of the tacton along with the player's heart rate, so instead of exposing horizontal and vertical scale separately, the designer can formulaically define both of these with respect to the heart rate. This means that an adaptive tacton's behavior can be entirely encapsulated within its design file, and it does not require any additional logic from the application. Designers can also test and view tactons in a 3D environment within the design tool. This environment supports creation of interactive elements, which can automatically modulate multiple external parameters. This feature allows iterative refinement and testing of adaptive tactons entirely within the AdapTics interface. Once a tacton design is complete, it can be exported to a file in a human-readable JSON format, to be included in the final end-use application with the AdapTics engine. To get an idea of the efficacy of adaptive features in AdapTics, we conducted a user study with 12 XR and haptic designers. The study involved A/B testing a non-adaptive version of the tool against the adaptive version. As part of the study, we had designers create tactons for each of these interactive scenes through open-ended design tasks. After completing design tasks with either version of the tool, participants filled out the Creativity Support Index Psychometric Survey. This survey assesses 6 dimensions, of which Exploration, Expressiveness, and the overall score showed significant improvement from the non-adaptive to the adaptive version of the design tool. More details about user study results, including qualitative analysis, is included in our paper. Thank you for your attention. If there are any questions or comments about this work, please feel free to reach out.